Good afternoon, everybody. Hello, and welcome to the webinar from AUTOMAITED about process automation with AI. AUTOMAITED is a company that helps customers to automate their tasks in a very simple way so we can free up time and increase productivity for the team by using AI. But today, we're not going to talk too much about AUTOMAITED. We're going to talk about three main goals that we have for our session today. First goal is that we want to create an understanding of the latest AI developments and what this means, and also then explain how AI ties into process automation. And this is going to be an important lever going forward to basically help your company work with AI in the process automation space. And to really get started, and for you, we want to give you some hints and tips on and explain how you can identify good use cases for automation in your company, and then start to looking for the right tool to do so. So let's start by defining some words and terminology, right? So what is AI, machine learning, or deep learning, right? So they are all somehow connected, and the framework exists for a long time already. So you see that the first artificial intelligence, also AI, started in the 50s actually. And it's actually, in its essence, a technology that enables computers to mimic human behavior, right? So, and in our times, you might know Siri, Alexa, chatbots on websites, computer game characters, or chatbots, for example, which are all mimicking human behavior to basically interact with you and support you in your daily doing. Then in the 80s, there was a new field developed, which is a subset of artificial intelligence, is basically machine learning, right? So machine learning is a way to train machines so they learn how to do something, how something works. And you do so by feeding it a lot of data, right? So in the end, this is something that you know, for example, from your Outlook or your email program, for example, junk filters, right? So if you give it a lot of emails and you always put emails into junk, the system learns by that. But also the same goes for recommendations apps. In case you go shopping online, you basically know that there's recommendations, and it's purely built based on the pattern how you shopped in the past. And likewise, it's also for web searches and the results that you get there. So this is basically a very powerful tool to train machines to learn based on data. And the next step, which is another layer deeper into that, is deep learning. Deep learning is basically an advancement of machine learning, which takes algorithms that learn patterns by filtering training data and going through it. So this is like your brain. So you need to think about it like a deep network of a lot of neurons that just learn how things are done by looking at them. And this is basically happening since the last 10 years, and now there's a lot of breakthroughs, right? So you see the new iPhones, they have all facial recognition, which is purely done by deep learning, because it's much harder to train those kind of layers, right? So that's one thing, or imagery in general, tagging, object identification is only possible with deep learning. This is nothing that is really possible or very hard to do with machine learning. So what is now the recent uproar about, right? So there's connected technologies, and there's actually a great interface added to it, and plus somebody spent a huge amount of time and money to really realize it. So if you take those three models, there's another thing that comes to it, right? So it's called natural language processing. Natural language processing is basically enabling computers to understand, interpret, and speak human language in brackets, right? So in spoken and written language. If you add those things up together and basically add a lot of information, you get a large language model or generative AI. So many of you might have heard about OpenAI's Chat GPT, which is basically a large language model that was pre-trained with a lot of enormous amount of text and data from the internet, right? So you need to know that there's ways to train a machine. So unsupervised learning is basically you throw information in, like downloading the internet, throwing it into a system, and the system learns based on the pattern it finds. But you then can also fine-tune this by label conversations, or in that sense, it's a supervised learning, right? So you basically tell, this is a dog, this is a good answer. And In the end, the next step and the last step is really polishing. So it's much more human-like, and you can't really at the end tell the difference to a human. And this is done by rewards and punishment, right? So you basically give a response to the action it has taken. So you say, this is a good answer. I would have done it differently. So that's also, if you've used Chat GPT, you will see those thumbs ups or thumbs down in the very corner to tell if it's a good answer or not. And the system will learn by this. So by training and making the system learn over time and being able to process and understand human language, we now have a very powerful model. And that's what the recent Uproar is about. So in the end, it's nothing new, but it's a great combination of different technologies like deep learning, natural language processing, and a great interface with a chat. But in the end, somebody spent a huge amount of money and time to really get this the right way. So to put a little bit more meat to the bone, let me show you what is needed to do so, right? So just to train the last model, there were more than 1,000 GPUs, so graphic processors, which are really, in the end, you can say very powerful computers required for 34 days for more than a month to process all the data without a stop, right? So 24/7, and literally another or in total $4.6 million have been spent to only train that model so it can do what it does today. So what can it do, right? So what are some examples of this recent Uproar? And there's many other models, by the way, coming, right? So Chat GPT is probably not the only one that's coming. So in Germany, we have Aleph Alpha, for example. So there's many other models, and you can literally do this also for any other stuff, right? So not only language or text, but there's any other things that you can train it for. So we come to that later in a little bit. So one thing where it can be used, where it's super powerful, by going through the internet, for example, it went through all the forums, all the knowledge around code. Right, so you can use it as a coding partner, which is super powerful today for engineering work. So you can find bugs in codes, you can help to extend code, and it's actually giving really good answers for that, how to fix code, how to extend code, how to write something. So if you want to learn coding, we actually can also ask it to help you learn coding over time. A second example is as a brainstorming partner. And here it's really powerful the more you interact and really chat and talk to it. Right, so you can come up, for example, with a question, how do you structure a webinar that's supposed to be 30 minutes long and talk about some major topics that we're now talking today? That's not how we've done it, but in theory, it's possible, right? And you can then, the best way to do is basically not to fine tune your prompt, but rather talk to the AI over time. So it basically builds on top and on top, and it's getting better every prompt. And there's a lot of research that is out there done from universities in terms of the best interaction with those large language models and how they produce the best results. So if you work with it, if you train it, you can actually achieve quite some significant results. And that's also what a lot of companies nowadays build upon, right? So if you see all those companies that do, for example, writing sales emails, doing specific smaller tasks, whatsoever, they are all very specific prompts or prompt chains that are put into GPT with a beautiful layer on top, right? So a golden layer that makes it look nice. But they all basically come back to the same brain in the end. Or also where I use it quite a lot is also as an explaining partner, right? So a simple way to do is what does a certain company do, right? And what I do is I go to the website, copy paste all the content, put it in there, say, can you explain me what the company is doing? And you actually get a super nice overview on what it is. And then, as mentioned before, you can even ask, okay, can you tell me this in bullet points? So give me the company name, the industry, and whatsoever. So it's really good to get answers in the structure that you would like to have it. And that's why it's so powerful, because A, it feels supernatural, the conversation. B, the output is actually great and very easy to understand, and you can fine tune it to your needs, right? So that's why it makes it super powerful as well, besides as it has massive knowledge. So there's many use cases that we could show here. The internet is full of things. Just Google it and you find a lot of stuff. Still, and that's something that I especially also want to call out, there's some risk coming with this advancement, and especially with the technology behind Chat GPT and so on and so forth, but also in general for any model that is trained, right? So a key one is bias to the data, right? So it's really core and key, and that's why it's great that OpenAI was more like a public funded non-profit organization at the beginning, you need to try to have unbiased data, right? So if you train it only with specific data, with specific data sets, the model gets biased. But also if you give it feedback in a specific way, so you only have, let's say, certain type of people giving feedback to that model, the data will be biased in the end, right? So, and thus will the outcome, right? So you need to have a representative set of data to make the model fair and not biased. That's one. The second thing is in misinformation, right? So it's not a scientific robot that knows everything. Sometimes information can be false or misleading, especially if the data is biased, but it's also hard to distinguish it from accurate information. So there's ways to tweak and let the AI talk in certain ways that are maybe misleading, which then could be faking news or impersonating individuals if you take certain technology. And this is very hard to come by. So that's something that's going to be interesting to see in future, how also is governments and in general, the world is going to handle those kind of things. Another one that's still a case is hallucination or the shallowness, right? So if you search, for example, on Google, you get a lot of search results. And you can go through and basically build your own opinion from different sources. With those models, or especially GPT, you have one answer, right? So it's like, it's giving you the best answer that the system feels or the model feels it has for you. And it's based on statistical predictions, right? So it could be wrong. It could predict something or have something in your question that is actually not what you wanted. And then it might be misguiding or might be hallucinating about what you actually want to hear. And lastly, and that's something that's probably going to be worked on very hard by those companies, because that's a pain point for a lot of current, especially corporate users, is privacies, right? So like, how do you mask or de-identify basically data, especially training data, so they don't leak private or proprietary data, so sensitive information. For example, GPT claims not to store any data, and that might be true, but like you never know where your data ends up, right? So that's something that's probably going to be a differentiator for a few models in the future to really make this technology available for large corporations that have a lot of secrets and proprietary information that shouldn't land in somebody else's hands. So having talked about this, how can AI, large language models, make automation more efficient? And there's maybe obvious and not so obvious things how they make process automation more efficient. But in general, you can say that the technology allows instant automation in a very, very fast way and of much higher complexity. Why is that? And there's actually you can condense it down to 3 areas. The first area is about the user interaction, right? So as mentioned before, the current language models are very easy to interact with. They're very human-like. They give good answers. It's easy to have conversations. So those AI-powered bots, they allow users to communicate very naturally, right? So there's companies that have implemented chat features to build code or also build automations, which is easy to talk to. So, but you can also train a model, right? And if you train a model or give certain conditions in like predefined prompts, you can also use it to navigate conversations, right? So if you have specific use cases or specific processes that follow a structure that are very common, can basically make sure that the system understands those processes. And whenever such a process comes up, the AI is guiding the user through a process. They navigate the conversations. But also, if set up in the right way, the AI would ask for additional context information to really make sure that the process or the problem to solve is really well understood. So is the data missing? I've seen this somewhere else. So that's making it more bulletproof, right? And you don't easily forget things that you might have forgotten in the past. So in the end, it's a very good and easy to use support for customers, and also allows the technology or the tools to move much further closer to the end user, right? So to non-technical people that maybe have not so deep technical knowledge, and makes it really easy, like a conversation that you would have over a lunch table, for example. So that's number 1. Number 2 is around data analytics. So as mentioned, all those models use a massive amount of data, and what they can also be used for to analyze massive amount of data. Right? So if you imagine that a process automation in any kind of form is taking a lot of, let's say, process information out of the system while a person or user is working, you need to somehow make an interpretation of this data. And with the new models, it is much more efficient, right? So you can do this in a better way. You can analyze patterns much better than you could in the past. And I'm going to show a very simple example in a bit. But also, I think that's a recent advancement that's super powerful. It goes beyond the data interpretation from like text and numbers, but also into imagery, video, and data recognition, which will be much more powerful in the future and probably will bring a lot of advancement in the fields of process automation. But also, it's an extra level or layer of depth, and it understands the requirements of the users and the user in the process better. And with that, it's also getting more efficient and clearer in any way over time. And lastly, and that's what I mentioned before, also with the coding partner, it can help to create automations, right? So in the end, what is an automation? It's something that is a code that's executed, or it's operations that happen in the future that need to be predicted, and they need to be created, and the code needs to be written. So those models, they can write and test code, right? So they can make sure that the code is written in a good way and it's easy to implement if done well. And it basically reduces the cost of creating automations, but also helps to make automations available instantly for more complex tasks over time. And it also allows to basically change and adapt automations much more flexibly than they have been in the past, because it's much easier to extract and change code in those automations nowadays. So this is really three important things to know about when it comes to large language models and all the technology around AI and deep learning and how they make process automation much more efficient. So what has this to do with process automation, right? So that's not a big question, super technical, but I think it's also giving a good context for different levels of knowledge. So hopefully you still bear with me for some time. So let's give a simple example. So this is what a computer sees when you work on. Each box here is a representation of an operation. So a click in the system, entering some data, reading or extracting some data from here. And in the end, the process is a sequence, right? So each color can be a different operation here. Stuff happens, and that's what the computer is seeing every time you click a button, you click on something, you write something, you move a window, whatsoever. This looks like a mess if you just see that data, right? So it's a lot of, let's say in this case, colors, a lot of different operations. There's no structure to it, right? And the good thing now in these days is this amount is massive. You have millions and billions of those data pieces. How do you make sense of those? And what now new technology can do is easily identify patterns, right? So they find triggers here marked in green, and also predictions on repetition, and basically understands different branches and processes, right? So if I see a certain pattern, for example, or I've seen a couple of different processes multiple times, and okay, this is when a process starts, this is basically the trigger for it, and this is what's going to happen next, right? So they would predict, now you're at this position, let me do the next X steps for you, right? So in this case, we just basically marked 6 new boxes, right? And in the case you see, the one process is orange, light orange, green, right? And it ends with green, and it's orange, light orange, and gray, and it ends in gray, right? So there's different triggers for different kind of automations. And this happens with a million and billions of input vectors, combinations that are possible. And it's about the sequence of applications that you use, the type of operation, is the data modified, and so on and so forth. So it's super, super complex. And it's a massive amount of data that you need to make sense of. And this is what we can do nowadays in a very simple way. So the technology really does magic here. In the end, as I said, it identifies patterns, right? It observes, in best case, the operations, the processes that are happening, identifies patterns, and then basically predicts the next operation. So by knowing certain triggers, this is what's going to happen next, right? And this can go from, let's say, very simple things like, this is probably going to be the next button that you click in, up to longer process chains where you say, okay, these are probably going to be the next 6, 7, 8, 9, 20 things that you're going to do, right? So it really depends on the complexity, and the models are getting better and better over time. And in the end, in some sort of way, it builds the automation by predicting your next operation, right? By knowing this, having the knowledge, by knowing what's happening. And here's an example, right? It's like orange, light orange, gray. Then the next colors will be purple, blue, blue, light purple, light orange, and gray, right? So like we've seen in the example before. And this is a very, let's say, hopefully a very simple way to explain how the new technology with all the advancements in like pattern recognition, large language models, and so on and so forth are going to facilitate how we create and build automations in future. Hopefully that wasn't too complex, and hopefully there was something that is easy to understand. But now what? Like how do we now find things to automate? Like how do we do this? So the simplest way is probably to find a tool, a vendor that's very proactive and helps you to find a couple of first automation, takes you by the hand, and basically makes sure that you get a feel for the technology and what you can do with it. In general, and there's probably many more dimensions that you can think about, or you can condense it down also to one or two if you like. Simply speaking, anything in theory that's more than one click has the potential to be automated, right? So if you execute an automation with one click, anything that has one or two clicks or more is basically already faster if you only need to do one click. Having said that, it's probably much more complicated, right? So in the nucleus, you need to think about is there's three different kinds of things that can happen. So either you have somehow data handling, right? So you extract data, you enter data, you modify data, add data, create data, whatsoever. That's number one. Number two is navigation. So you might click in the system, you might scroll, you might need to wait. So there's navigation that you need to do in this process. And thirdly, there's, let's call them special operations, like downloading, uploading a file, or something that's very specific to the application that you're working in. And that's the things that you need to look into. The smaller, let's say, the combination of complexity of those three forms of operations are the easier, right? So if it's only navigation, it's probably very simple to automate. If it's only, let's say, data entry and modification, also very simple. If you start to combine those elements in a longer process, then it's getting complicated. What is really easily possible today, and I'm going to come to those 8 dimensions in a second, so bear with me, is like doing all those small things, right? So in theory, it's very simple to build an automation / a smart button for all the small operations that you then over time can tie together to basically represent a full process. So one thing to think about when thinking about what's a good use case is about the repetition. And I'm always going to give you an example like how new technology versus old technology looks here. So one is the repetition, and this means like how frequent do we execute the process or the task that we're currently looking at. So classical automations, they are more, yeah, you would say you need to have a lot of repetition, so it's worthwhile to do this. Now with the AI, as mentioned, it's like so easy to create new automations because the AI is helping to create those, and it's very fast. That's why it's also worthwhile to like go for really, I wouldn't say tasks that you maybe do once a year, but if they are done once a week, once a day, a couple of times a month, that's fine to look at those, right? And this paired with like the volume, so there's different dimensions to it, right? If you then think about it, maybe lower frequency, but a high amount of data or transactions that are within those. So if you, let's say, maybe once a month need to like copy paste hundreds of data points, that's a lot, right? Or if you, let's say, have to do 2 or 3 data points, but you have to do it every day, that's also a very good combination. But also here, old tools, like they work well, and they're like having a good return on investment if there's a lot of data and a lot of transactions involved. While new technology also, again, makes it very simple only for smaller tasks or processes. A third dimension goes along clarity. So how clear are the rules? How simple are the rules? Can I formulate really clear guidelines? And why this is important is, in the end, the old tools, they're really dependent on those rules, right? And like they try to do it end to end in a long chain of processes. You wouldn't like go for an old process there. I only want to have, let's say, an automation for like copying and pasting those 2 values because that's too complicated to realize. Nowadays, because it's very simple, it's also fine if the rules are not so clear and you basically separate the process out into smaller steps where the rules are clear, but not for the full process, right? So you can basically also build better in terms of variations, right? And that's what we come next to. So how do you basically cater for exceptions or variations in the process? And as said, it's a similar view here, right? So variations are costly with old vendors because you have basically rebuilt the whole process just with a different branch in there. Again, with new technology, this is very easy to understand, but also in worst case, you basically just, yeah, you have done it once, it recognizes the pattern, it's just a different outcome, so the system will know. The order of steps, the structure in this case, how consistent is that, right? So in this case, also the consistency of those steps. Do you always need to do it in this way or the other way around? It needs to be consistent. Otherwise, you need, again, to split up the process if you do it end to end. And you don't want to have, let's say, super small automations that are very costly. And often also vendors don't give you 10, 20, 30 automations because they always like they charge per automation, which is super hard. New technology really allows it to, let's say, break it down into its parts and allows being much more flexible with the variety of steps or the structure of a process. Another dimension, and as said, don't take all of them to analyze a process. Take one or two of those and see, okay, is there a lot of volume? Can I clearly formulate it? And I'm going to give some examples in a bit on basically how this could work. Is time consumption. Is that something that's taking me a lot of time to do, right? So is the operation that I have to do like complicated? So maybe I have to type in stuff, or like I have to think about like how do I combine this and copy and paste from different elements. So again, old vendors, really long processes, high time consumptions. Today, as it's so simple and easy to do, with new and AI-supported technology, I also say you can literally create an automation for copy and pasting the agenda every week into your meeting notes. Two more, bear with me. Another one is the error likelihood, right? So what's the risk of making mistakes? Old RPAs need to be really error prone, right? So like they need to work, and similarly need the new ones, right? So in that sense, if you have an automation, you train them well. If there's no changes, they work, right? So I think that's where they're both on par. There's no difference. If an automation works, they're not going to make mistakes. It's like it's a machine, it's a robot. You just like run through it. One important thing, though, to note to that is the consistency, right? So other vendors or old vendors, they basically need to work with like very consistent processes. They can't change too often because you always need to go back, adapt the processes. People need to come in and change things. With new technologies, very easy to cater those, right? So as mentioned before, within the process, you can tell the AI to basically adapt the process while you're actually executing the process, or the AI learns that certain things in the process are different and actually will adapt to that on its own. So that's a couple of dimensions to think about when thinking about what are good use cases. Next page, and I see that somehow there's an error in this presentation here, but you can think about like, if you can write it down, it likely can be automated, right? So one thing to think about, the fewer applications you work with, the easier the operations, the clearer the rules, the faster or easier it is to automate something. So one simple example is, on the left side you see is like copy paste, right? So like the process that includes many fields or data points that need to be transferred or entered to be error prone, that's something that the automation can take off, right? So they basically learn how to transfer data from A to B, modify the data along the way in desired format, and you don't make errors with that, right? So automation is there. So copying, pasting data from A to B with modifications, very simple. I don't know why the animation is missing here in the middle, but we have a beautiful picture here as well. It's system navigation, right? So processes where users always follow a certain flow or path within a system, they always need to click, for example, in SAP, LinkedIn, HubSpot, whatsoever, certain buttons or navigate somewhere to basically get to a certain point where they want to be. That's something that's also easy to automate, right? So the automation can take care of all the parts of the navigation, which used to be maybe 3, 4, 10 clicks in the past. Now it's basically one click of a button, as you see on the left and right here, with the buttons to execute all those steps. Or another example might be text or data handling, right? So as mentioned, now with the AI and the technology that we have, processes where there are gaps in data that need to be filled. So I don't know, there's a zip code missing, there's some information, a last name missing, whatsoever. Like data can help to fill those gaps. Or also summarize information. So in customer service, for example, you might summarize a customer complaint. Or you might be able to compare data. Is my invoice here in the system the same to another? So as the new technology and the language models and all the other tools that are out there are able or easily combined today, you have much more flexibility and can add missing data pieces, summarize text in a defined structure, right? So I need to have the data in a certain format. Can you please extract it and give this to me in the process, or highlight mistakes? Right, so we can, and if interested, please reach out to me. I can help to advise on what are potential use cases, but in the end, stay with the rule. If you can write it down and, for example, explain it to an intern or outsource it, and I think that's always a great example, is if you, for example, use an outsourcing center or somewhere where you can basically outsource the processes at scale, and you can explain them in an easy way how it's done, that's very easy to automate, right? And let's start with this and take one step first. And once you have understood the beauty of process automation, we then can go further and you can really do crazy things. And maybe we're going to elaborate on this in another webinar. There's literally hardly limitations on how you can use AI in a process and build crazy things that you couldn't have done before. And probably it's then going to change the way how you work. So hopefully in this webinar, we have shown you what the current AI trends are about, what AI, machine learning, language models, large language models, and so on are, how they tie back to process automation and how they can help. And in best case, you now have a good idea on how to think about processes where you can automate and go back to your team or your managers and say, hey, I have an idea on things that we can automate. There's many vendors out there, so we're not the only good ones. Also happy to advise on that. I'm very open in those conversations. I'm very happy that you joined us all today. If you have any questions, please let me know in the chat or write me an email. And if you're ready to automate processes, you can also book a demo on our page. As said, AUTOMAITED is one of the few companies that actually use AI in a very good way today to make automations really simple. And that's it. Have a nice afternoon, and thanks for tuning in. And I hope this was insightful. And see you soon. Thanks a lot.